Hello, this is Professor Shannon Gracie from MiraCosta College. Again, continuing with beginning algebra, and we'll be going over problem solving in geometry for this lesson. So we'll be using, familiar formulas for perimeter and area, also circles, area and circumference, volume formulas, and triangle problems, angles of a triangle, and then complementary and supplementary angle problems. So why don't you go ahead and do the warm-up, pause the movie, do the warm-up, ready, set, go. Okay, let's see how you did. If we let B be the original price, do you see that we would have 100% of the original price minus 30% of the original price would be equal to the discounted price. So here, this would just be 1b minus 0.30b would be 98. And this, of course, would be 0.7b is 98. If we are to multiply by 1 over 0.7 on both sides, or divide both sides by 0.7, we would have 1b is equal to 140, so b is equal to 140. So let's give our answer in words. The selling price before the reduction was $140. Okay, so moving on with today's exciting material. Here are some common formulas for perimeter and area. So this here is meant to be a square. So if you call each edge S, what will happen is the perimeter, this looks a little not like an S. So the perimeter, do you guys see that there are 4 S's here? So the perimeter will be 4 S's, and that's in linear units. And the area will be, what do you think? Length times width for a rectangle, right? So side times side units, but this is commonly written as the area is the side squared, and these are in units. We'll just, we'll write them as square units. We'll write out that word square. Okay, so, and this of course is a square. This is a rectangle. And remember, we already discussed rectangles at length. If we call this here the width and this the length, the perimeter is equal to 2L plus 2W. Now let's put our units down. I'll put parentheses around it and then say units. And then remember, the area is length times width, and that's in square units. Okay. All right, so next up we have a triangle. Now for a triangle, in order to figure out the perimeter, you just need to have your, if you call this, A, B, and C, right? Well, I don't want you to get confused about, let's call this B for base, all right? And then we'll call this A and C. So do you see the perimeter is the sum of the sides of the triangle, which would just be A plus B plus C. Now for the area, we need to know the height. The height makes a right angle to the base of the triangle. So the area, and this is in, the perimeter is in linear units. The area will be half times base times height, and that is in square units. Now, trapezoid is the next step. I used to always get a bit confused by the formula for a trapezoid until I recognized that the area, we'll do the area first, okay? Again, similar to the triangle, you want to have a height measure. The height forms a right angle with the bases. And if this guy here is called base 1, and this here is base 2, okay, then the area is the average of the bases. So that would be base 1 plus base 2 divided by, good, 2 times the height. And that's in square units. Now, most books end up writing it like this. I mean, they usually write it something like half, the area is half times base 1 plus base 2 times the height. And do you guys see that's the same formula? So the main thing to remember here is that the area is the average of the bases times the height. I'll write that in. Okay. Now the perimeter will just be equal to the sum of the sides. So, you know, you would add up, you'd add up this plus this plus this plus this. That would be your perimeter P. Okay? All right, 1 down, 8 to go. Long section this time. All right, so let's take a look at this problem. So most importantly is you need to put down the formula that you're going to be using in its entirety, not just one side or the other. So if you take a look at this guy, we've been given the triangle's base and the triangle's area, right? So we would say area equals 1/2 times base times height. Now what was that area? Good, it was 30 half times, now what else were we given? Good, the base is 6 times the height. So we have this base of 6 feet is where we're getting that. The area is 30 square feet. We'll do the units at the end. Now notice that 2 goes into itself once and into 6 3 times. So we end up with 30 is equal to 3 times h. And then if we multiply both sides by 1/3, the 3's divide out over here, and we will get 10 is equal to 1h, so that means h is equal to 10. So we'll write our conclusion. The triangle's height is 10 feet. Okay. All right. Next up, we have a rectangle, has a width of 46 centimeters and a perimeter of 208 centimeters. What is the rectangle's length? So notice we were given perimeter of 208 centimeters. So why don't we write down the general formula for perimeter, 2 L's plus 2 W's. And for perimeter, we're going to put 208 because that was given in the problem. Now, what else were we given? We were given, good, the width was 46 centimeters. So we have information for the width here. So this will give us 208 is 2L plus, what is that, 92, I believe. Now we want to subtract 92 from both sides so we can isolate the L. So we will end up with, I'll bring this all over here, we'll end up with 116 is equal to 2L plus 0, so 116 is 2L. Now if we multiply both sides by 1/2 so we can isolate the L, the 2's will divide out, and then over here I believe we'll get 58 is equal to L. So then in words, the rectangle's length is 58 and our unit was centimeters. How are we doing so far? Isn't geometry fun? Okay, so here we go. Now we have a trapezoid. We need to find the area. So, do you guys see that we need to find the height of the trapezoid? What do you think the height of the trapezoid is? Good. The height is going to be this 4-meter measure right here. That's our height. And then, what are our bases? What would our first base be? Good. Our first base would be the 5. So this was our height. Our first base is this 5-meter measure. And then our second base is going to be the 8 meters. And we'll do the units at the end. So base 2 is 8 meters. Okay. So the area, remember, is the average of the bases. So B1 plus B2 divided by 2, and then times the height. So the area will be 5 plus 8 divided by 2 times 4. So this is what we plugged in for everything. Now notice that we can go ahead and divide this 2 out, right? And then our area will end up being, we have to add the 5 and the 8 first to get the 13, and then we can multiply that by 2. So the area will be 26, and that's in meters. And remember, area has square units, meters squared. So let's just write it in words. The area of the trapezoid is 26 square meters. All right, on to geometric formulas for circumference and area of a circle. A circle is the set of all points in the plane equally distant from a given point, its center. A radius, the plural for radius is radii, and it's usually denoted by r, is a line segment from the center to any point on the circle. So for a given circle, all radii have the same length. So let's go down. We'll come back to all these words, but let's go down here and let's draw in the center of the circle. Okay, center of the circle. And then, so a radius of the circle, one radius would go here to here. See, it goes to a point on the circle. Right? So this is a radius of the circle. Okay. Now, come back here. A diameter D is a line segment that goes through the center whose endpoints both lie on the circle. For a given circle, all diameters have the same length. In any circle, the length of a diameter is twice the length of a circle, and the length, oh, I apologize, I'm making up my own math here. Don't forget to stop me when I do that. Twice the length of a radius, and the length of a radius is half the length of a diameter. There's a relationship there. So let's go ahead and draw in the diameter of a circle. So notice if I did, do you see that would be a radius? And if I kept going to the other end, I would then have a diameter. Okay? Alrighty. So, the area of a circle turns out to be pi r squared, square units, and the circumference of a circle can be written two ways. You can write it as 2 times pi times r, and that's in linear units, or you can write it as 2r is a diameter, so you could write it as pi times d units. Now on my website, I believe I have an animation for one of these formulas. I think it was for the area of a circle. So if you just go to mathcheck.net and click on that link, that'll give you a little more information about why that is the area for the circle. Okay? But back to the lesson at hand. Let's figure out how to solve some of these problems. So find the area and circumference of a circle which has a diameter of 40 feet. Diameter of 40 feet. So what do you guys want to find first? We could find the circumference, right, using diameter directly. We could use that one, pi times d. So the circumference will be pi times 40 because the diameter was 40. So the circumference would be, we usually put the 40 first, times pi, and that's in feet. Now if somebody was asked for an approximation, you would often use 3.14 for pi, and then you would get an approximation, but we're just getting an exact result here. Alright, so the area of a circle, remember, is pi r squared, but we don't have r. So how are we going to figure out what r is? Remember that, wasn't the diameter double the radius? And don't we know that the diameter is 40? So do you guys see that we'll use that information twice, and if I, multiply both sides by 1/2 to isolate r, then I would get that r, the radius, is 20. So coming back here, I can now figure out the area. And so we will get pi 20 squared is going to be a 4 with 2 zeros. So the area will be 400 pi, and that's square feet. All right. Next up is a problem, kind of a comparison type problem. So which is a better buy, a large pizza with a 16-inch diameter for $12, or 2 small pizzas, each with a 10-inch diameter for $12? So here, I mean, you wouldn't really be interested in the perimeter because you're not just eating the crust, you're eating the whole pie, right? So what we'll do is we'll say area is equal to pi r squared, okay? And we'll do it both for the large and then for the small, and then we'll figure out what the better buy is. So for the large pizza, do you see that if d is equal to 16, right? Remember that d is also the same as 2 r's, okay? So d is 2r, and so therefore the radius will be 8 when you multiply both sides by 1/2. So here, when we do our area, we'll have the area is pi times 8 squared. So the area is 64 pi square inches. Now, the small, so for one small pizza, they had a 10-inch diameter. So diameter is 10. Remember, diameter is the same as 2 r's. So again, r will be 5. Using that relationship. and then multiplying by a half on both sides to get that result. And then, so the area for one of the smalls will be pi times 5 squared. So the area would be 25 pi square unit, or square inches. But don't we have two of them, right? We have two of them. So if we have two smalls, right? So two smalls will be 2 times 25 pi, which is 50 pi. One large was 64 pi. So do you see that the better by one large pizza is the better by? Because it has a larger area. Okay. Geometric formulas for volume. Volume refers to the amount of space occupied by a three-dimensional figure. To measure this space, we use cubic units. So here we go. Here's some common formulas. So this is a cube. And so for a cube, all the edges measure the same. All right. So the volume is S times S times S. So we get S cubed, and that's in cubic units. All right, so now here we have a height measure, we have a length measure, and we have a width measure. So it's just like the area of a rectangle times its height, right? This is considered a rectangular solid. So the volume for this guy is length times width times height, and again that's in cubic units. All right. So a sphere, this is a sphere, and a sphere has a volume of 4/3 pi times the radius cubed, and that's in cubic units. A cone, right? And actually, you know, there's one shape I should have included in here, all right? And that is a right circular cylinder, right? So you have a height measure like this. This is a height measure, and then this is a radius measure. We do the radius in a different color. Radius measure. So the volume, okay, for a right circular cylinder volume is pi r squared, that's the area of the circular base, times the height, and that's in cubic units. And the reason I wanted to give you this shape is because the volume for a cone is just like the volume for the cylinder, but you divide it by 3. That's in cubic units. Okay? So again, any derivations for these formulas, I have some of them on mathchick.net, and you can go look for them online. There's great animations of these things online. Okay, let's look at these next problems. Solve the formula for the volume of a cone for h. So remember, volume for the cone was pi r squared h over 3. We want to isolate h. So if I multiply both sides by 3, then I'll be on my way. I'll get 3v is pi r squared times h. Now, do you see, if I were to multiply by 1 over pi r squared on both sides, the pi's would divide out, the r squareds would divide out, and h would be isolated. It would have a coefficient of 1. So we would get 3v over pi r squared is equal to 1h. So h, of course, would be 3 times the volume divided by pi r squared. All right. Next up, we have a cylinder with radius 2 inches and height 3 inches. Has its radius quadrupled. How many times greater is the volume of the larger cylinder than the smaller cylinder? Well, let's see. Let's do the smaller one first. Okay. So, volume is pi r squared h. The radius was 2 inches and the height was 3 inches. So, pi 2 squared times 3. So we would get 12 pi. Now, the larger will be, if you quadruple, so 4r would be 4 times 2, which is 8. So the volume will now be, again using pi r squared h, we'll get pi times 8 squared times 3. So this will be, you get 64 when you do the 8 squared, and then if you times that by 3, you're going to get 192 pi. Now, how many times greater is the volume of the larger cylinder than the smaller cylinder? So you have to be a little bit careful. They don't want you to consider how much the same, okay? Only the many times greater. So to get that one figured out, what we would do is do this ratio. We would do the ratio of 192 pi minus 12 pi, so I'm subtracting out what is the same, and we're going to compare that to 12 pi. That's going to be, I believe, 180 pi divided by 12 pi. This is the ratio of 180 pi to 12 pi, and then that's going to be, let's see, 15, because the pi's divide out, and 180 divided by 12 is 15. So let's answer the question. The volume of the larger cylinder is 15 times greater than the smaller cylinder. All right. Now this one's a little more straightforward. Why don't you guys try this one on your own? So go ahead and pause the movie and give it a shot. Ready? On your mark, get set, go! All right, let's see how you guys did. The volume of a shoebox would be length times width times height. So we can call this, 6 times 12 times 5. So the volume is going to be equal to 360, and now it's in inches cubed. Okay. How'd you guys do? I bet you did really well on that one. Alright, so now we come into angles of triangles. An angle symbolized by this symbol is made up of two rays that have a common end point. The common end point is called the vertex. The two rays that form the angle are called its sides. So if you just kind of were to take a look at, let's see if we can kind of let's do this one. And let's just start like this. Oh, I didn't want that one. Those are kind of odd. I think I'll just draw it myself. So here we go. You have one ray. Now a ray has an end point and then it goes kind of infinitely in one direction. And here's the end point of one. And just imagine kind of rotating that ray and kind of going doot, 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 and let's say it terminated here. So each of these are considered this is a side, each of these are rays. Here's another side. And then this point right here, this point here is considered the vertex. And then we'll often say this for, angle. Alrighty? One way to measure angles is in degrees, symbolized by a small raised circle. So it would be up high like this. There are 360 degrees in a circle. 1 degree is 1/360th of a complete rotation. Alright, so the angles of a triangle. The sum of the angles, the measures of the three angles of any triangle. This is really powerful. Any triangle, the three angles measure 180 degrees. So you could draw a triangle any old way, that you wanted, and it would always come out to, the angles always sum to be 180 degrees. So if we were to, let's just make a triangle. So if you call this angle A, angle B, and angle C, and then usually the way well, I won't. Usually what they do is they'll say the side opposite will be like lowercase a, so it'll be lowercase what the angle was named. But it turns out that a plus b plus c is always equal to 180 degrees when you're in degree measure. Complementary and supplementary angles. Two angles with measures having a sum of 90 degrees are called complementary angles. Two angles with measures having a sum of 180 degrees are called supplementary angles. So the first situation, do you guys agree this would be 90 degrees? And so if you had, say, angle A here and angle B here, then you'd have the situation where A plus B was equal to 90 degrees. So this box means 90 degrees. Now, if you take a line, right, a straight line, and you have an angle coming out like this, or a ray coming off it like this, and if this is your A and this is your B, then in this case A plus B would be 180 degrees. All right, we're moving right along on page 8 out of 9. Okay, so here we go. One angle of a triangle is 3 times as large as another. The measure of the third angle is 40 degrees more than that of the smallest angle. Find the measure of each angle. Okay. So, let's see. We have a triangle. And we know that the angles of a triangle sum to be 180 degrees. So right away, we're halfway there if we say equals 180 degrees. We'll put the degree in at the end. Now let's deal with this first one. One angle of a triangle is 3 times as large as another. So if we were to let x be the measure of the smallest angle, then we would have 3 times x for the blue. Now, actually, that should be in the middle because I'll have, do you see, I'll have x plus the 3 times x because you have to add that original smallest angle in there. And then the measure of the third angle is 40 degrees more than that of the smallest. So x plus 40 is going to be representative of this third angle here. Now we can just combine our x's. Do you see we have 5 x's plus 40 is 180. Subtracting 40 from both sides, we will get 5x plus 0 is 140. So we have 5x is 140. So if we multiply both sides by 1/5, divides out these here, and we'll get x is equal to 28. So now do you see we also need to find 3x. So 3x is going to be 3 times 28, which is going to be 84. And we also need x plus 40. That's going to be 28 plus 40, which is 68. So the measures of the angles are 28 degrees, 84 degrees, and 68 degrees. All right, here's some practice with complements. So remember that the complement for each angle, we have to figure out what number, when added to 56, gives a result of, 90 degrees. So if you do the same type of thing, you'd have x plus 56 degrees must be 90 degrees. So if we were to subtract, we'll just leave the units in this time, we would get x is equal to 34 degrees. So the complement of 56 degrees is 34 degrees. Okay, similarly, x plus 89.5 degrees is 90 degrees. Subtract 89.5 degrees from both sides of the equation. X is going to be equal to 0.5 of a degree. So again, for this one, the complement of 89.5 degrees is 0.5 of a degree. Okay. All right, similar for supplements, except we're now equaling them to, 180 degrees. So x plus, I'm just going to leave the degree out until the end this time. X plus 177 is 180. Subtract 177 from both sides of the equation, and x will equal to 3. So the supplement of 177 degrees is 3 degrees. So now x plus 0.2 of a degree is equal to 180. I'll leave the degrees out till the end. Subtract our 2/10. So we will get x is equal to 179.8. So we found that the supplement of 2/10 of a degree is 179 and 8/10 of a degree, 8/10 degrees. All right, next up, the measure of the angle's supplement is 52 degrees more than that of its complement. So here we go. The measure of the angle's supplement. So do you remember that when we isolated x, when we were finding the supplement, we really were doing 180 minus the given angle, right? So here, if I want to go from that angle of it, I would say 180 minus x is the supplement of x. Okay, so this is the yellow. Now, is 52 degrees more than twice that of its complement? So I'm going to just do plus 52 for the 52 degrees more. I'll put the degree in at the end. Okay. And twice that of its complement. So we're doubling the complement. And remember, the complement of the angle would be 90 minus x is the complement of x. So twice that of its complement is this part right here. And then it's just a matter of solving. So we have 180 minus x. Let me show you the distribution. I'll be distributing that 2 times the 90 minus 2 times x, and then adding 52. So 180 minus x will be 180 minus 2x plus 52. Now, do you notice that if I were to subtract 180 from both sides, I would get 0 minus x is 0 minus 2x plus 52. So I get negative x is negative 2x plus 52. I'm going to go ahead and add that 2x to both sides. And we'll get 1x is 0 x's plus 52. So x is 52 since 0 times anything is 0. So the angle measures 52 degrees. Okay, last page. Last page. So here we are. How are we going to figure this out? I mean, what do we have? We have a circle, and we have this square inside the circle, or is it a rectangle? I don't know. Let's see what we have. If you look here, do you see this also has to measure 12 inches? Actually, I have to confess and I think you're somewhat affected by this, the screen is stretched. This is supposed to be, let me just give you this information. This shape inside is supposed to be, this is supposed to be a square. And I apologize ahead of time if you're seeing when I project it in the classroom, it shows up truly as a square. But when I am in my when I am on the screen, it's somewhat stretched. So this is supposed to be a square, and the other shape, of course, is supposed to be a circle. So given that information, this here has to measure 12 inches as well. This has to measure the 2 inches. So do you see that we will have a circle with radius is equal to, or actually let's just look at the diameter. Do you guys see that the diameter would be 2 plus 12 plus 2? So the diameter is going to be 16, and that's in inches. So remember, diameter is the same as 2 times the radius. So the radius will have to be 8. And these are in inches. Now, the area of the shape of the shaded region is going to be the area of the circle minus the area of the square. So the area of the shaded region will be pi r squared minus the side squared. Area of the shaded region will be pi times 8 squared minus 12 squared. So the area of the shaded region will be 64 pi minus 144. That's in inches squared, so this would be the exact result. If we wanted to approximate that, we would say 64 times 3.14 minus 144. So that would give us an approximate result of 56.96 inches squared. This is approximate. Okay? Now normally, especially if you're not using a calculator for this first exam, so I'd be looking for the exact result. And that's it for this lesson. Have a fabulous, fabulous day. Bye.